Testing, testing. Hello, hello. If you're watching this stream, you may have noticed this is going to be my first stream that is actually not live. I am recording this on September 2nd at 9 p.m. Eastern Time, and I'm going to set for this to release on September 3rd at around 5 p.m. Eastern Time. The reason being is September 3rd is my girlfriend's birthday, and I'm going to be pretty much out of the house all day, having fun with friends and family, and I'm very much looking forward to sort of taking a little bit of a break, but still wanted to make sure that you all got your video. That way we can continue on our daily progress. So while it may not be live, well, I guess for you it will be live. It's really like it is live. You might not be able to interact with me, but we're going to continue going as if everything had been live. So I appreciate everyone that's been with me through all this. I'm going to keep this one to be a little bit shorter. It's going to be half an hour. We'll see how many questions we can get through. And without further ado, let's go right into it. So we're going to start off with this one. Most frequent number following key in an array. All right, so you're given a zero index integer array nums. You're also given an integer key, which is present in nums. For every unique integer target in nums, count the number of times target immediately follows an occurrence of key in nums. In other words, count the number of indices I such that 0 is less than or equal to I, less than or equals to nums.length minus 2, nums of I equals key, and nums of I plus 1 with target. Return the target with the maximum count. The test cases will be generated such that the target with the maximum count is unique. Okay, so for every unique integer target in nums, count the number of times target immediately follows an occurrence of keys. Okay, so for target 100, there are two occurrences at indices 1 and 4, okay, which follow an occurrence of key. No other integers follow an occurrence of key, so we return 100. For target 2, there are three occurrences at indices 1, 2, and 3, which follow an occurrence of key. For target 3, there is only one occurrence at index 4. And where is target 3? 0, 1, 2, 3, 4. Oh, okay, I see. Which follows an occurrence of key. Target 2 has the maximum number of occurrences following an occurrence of key, so we return 2. Now it wants me to return, let me see, the key is 1, so the number that follows the maximum times after 1. Okay, for 2, what is the number that is the most after 2? There's 2, 1, 2 here, okay. The test cases will be generated such that the answer is unique. So it's almost like, let's think about this. The key is 2. For target 2, there are three occurrences. For target 1, oh, it looks like someone subscribed while I'm recording. That's funny, because normally I do this live. But Rune Wizard 702. Rune Wizard 702's Dominion has subscribed, so thank you very much for subscribing. I truly do appreciate it. What is it that they want here? For target 2, there are three occurrences at indices 1, 2, and 3, which follow an occurrence of key. So every time we find key, we need to find how many numbers are there after. Is that what we're looking for? So we find key. How many numbers appear after 1? Like the frequency of numbers after 1, including 1 itself, I guess. 100 is the most. So I guess if we start from the end and we find 1 here, maybe we can say, okay, so far it's 100. Then we come to 100, and maybe here we can also say so far it's also 100. Return the target with the maximum count. The test cases will be generated such that, what if we just take the frequency of 100 and 200, and then I guess after 1 we just count the thing with the most frequency. I guess like what would be, we have 3. After this 2 we've seen 3 once. After this 2 we've seen 2 and 1. After this 2 we've seen 2 and 2. After this 2, we've seen 2, 2, 2. So we want to know which one has the highest frequency based on that. I think I sort of understand what they want. No other integers follow an occurrence of key. 100, 1, 200, 100, 1. What is the, I guess it's almost like at every point we want to know what number that is not key has the highest frequency. I think that's what they want for us to find out. And I almost wonder if we can do that sort of with like a heap, because how else can I keep track of? I mean, I could pick an arbitrary number. Or is there another way that we can do this? For target 2, there are 3 occurrences at indices 1, 2, and 3. Yeah, maybe we can do it with a heap, where like the heap just keeps track of frequencies of numbers. And every time we see a 1, we ask ourselves, what is the thing with the highest frequency? 200, 100, then we get to 1. The thing with the highest frequency is 1. Or rather, is 100. Right, so we see a 2, it's 3. We see a 2, it's going to be 2 or 3. That's fine. We see a 2, it's 2. Now, if they each have the same, count the number of indices, and will there always be one? Okay, it's unique. Yeah, I think I almost want to make a heap here. Wish there was like a more simple way, and there probably is, but this is what I'm thinking, at least off the top. And I'm going to have to see, let me see, LeetCode environments. Okay, so here in JavaScript, let me see, data structures, JS priority queue, and they want version 4.1. That's going to make it a little bit annoying. We're going to have to find, is there a branch? Okay, yeah, version 4.1, was it? Okay, so let's see how to use this. If we want a max priority queue, how can they, it'd be nice, I want to see how they do it with, okay, front example, DQ empty to array. What's a nice way for me to use this? The priority is a prop, on queue element priority, in priority example, or priority is the turn, for example, on queue patient Y, Z, where priority is the bid, for example. How can we say, how can we like add, I mean, can we, can we just say, this one's a little bit tricky. If not passed, the priority should be passed with on queue, bid.value. There's not very many examples here of how to use it. Name value, bidders back, example, DQ front, priority. Can we just get the priority? Is that something that we can actually do? Like if I did, well, I mean, let's just try it out. Max priority queue. The priority is a prop of the queued element. Okay, what if we just did this? So I'm going to create a max priority queue equals new max priority queue. What if I just did that? Now for nums, for const n, wow, why am I, for const n of nums, max priority queue dot on queue n. Oh, and I want to see what max priority queue has. Hopefully there's like a nice way for me to see this. I don't even know if that's actually going to work just like that. Yeah, it's not really gonna show me. On queue front back, DQ is empty, size to array, clear, construction, front back, DQ. I guess we can do this while size we can do while max priority queue dot size is greater than 0, we'll console.log max priority queue dot dequeue. Hopefully this will give us the individual elements, because what I want to do. Okay, now how can we increase the priority? It's almost like every single time, if it has the number, can we even check if it has the number? Back, front, on queue, adds an element with a priority number to the queue. So I have sort of a weird way of perhaps doing this. This is what we're going to do. We're going to create max priority queue, and we're also going to create a frequency. The frequency is going to be a priority. Right, so for const n of nums, we're going to say frequency of n equals frequency of n plus 1 or 1. And then we'll do max priority queue dot on queue. And it says here we can pass element and priority. So we'll pass. Oh, and you know what? We need to do this twice. We need to count the frequency once and then go through it again. And then here what I should say is max priority queue. The element's going to be n, and the priority will be frequency of n. All right, so now let's see what we get. Max priority queue, this should be dot on queue, because what I'm thinking of doing, priority 222 element 100. So why does this have priority 2 element 100? Okay. Priority 2 element 100. Does it push it twice? For const n of nums. Oh, I should only push what's inside of, yeah, that's going to be even crazier. So this will be for const, let's see, num and frequency, numFrec of object.entries of frequency. We're going to push num, and we'll get the frequency like this. 2 element 100, 2 element 1, 1 element 200. Not sure why it's going in there. Oh, because it's also, I would like to have this parse int. I would like that to be a number and not a string. Priority and L. Oh, okay, wait. Yeah, it needs to actually be. Let's do frec here. And let's do parse int of num, because it's setting it as a string. I need it to be a number. Okay. So I think what we could do now is, like, every single time we get to a 1, let me think about this. What's the thing with the highest priority? Priority 2 element 100. Yeah, because if I push everything, like what I'm trying to do is, like, I start at 100, right? And then I go to 1, and I say, okay, whenever I see a 1, what is the thing with the highest frequency? Okay, that's 100. That becomes like our new max. Then I get to the next one, and I see, okay, what thing has the highest frequency now? It's still 100. Cool. So it's like I need to be increasing frequency of things as I go along and always getting the thing with the highest frequency at the end. But how do I make sure that my max priority queue does not get... I just want to try something again for my own. Max priority queue dot on queue. I'm going to remove all this. So if I put element n and frequency of n. How does this look again? Priority 2 element 100, priority 2 element 100, priority 2 element 1. I guess this has the highest, but why wouldn't it be? You know what? I mean, let's go for it and see what happens, right? So we can say let max priority queue, and then we can say let max equals some like very low number, or maybe we'll just set it to 0. Can this be negative numbers? Okay, it can't be. So what I'm gonna do is I'm gonna say for let I equals nums.length minus 1, I greater than or equal to 0, I minus minus. So here we'll just say that the frequency of nums of I equals the frequency of nums of I plus 1 or 1. Now if nums of I is equal to key, we want to see there's like element and priority, right? So we need to say if nums of I equals key and max priority queue dot size is greater than 0, here we can say that the max value is the math of max or max priority queue. And so I think front returns the element with the highest priority and element. So we should say front, and from here we get the element. And let me think about this. So where else do this, and we're also adding into our priority queue. So max priority queue dot on queue. Here we can say element, which is nums of I, and frequency of nums of I. And then at the end we return max. Very curious to see if that will work. Sort of a weird answer. 100 and 100. Okay, 103, and then we got 102. So why would it have been 2? That's a very curious thing. Oh, because we're never, if nums of key, math.max, probably I should still check to see. Yeah, I feel like I should always be doing this. Still the same thing, huh? 2223. If nums of I equals key, so we're gonna add 3. 3 is gonna equal frequency of nums of I. Okay, 3. Then we go to 2. Okay, if nums I equals key, 2. But now we're adding element and priority. We're increasing the priority of this every single time. So how can it be that, how can 2 not have the highest priority in here? Oh, it's not the max, right? We need to get, I see. Maybe it's not. Yeah, no, it shouldn't be. If it's 2, we want the thing with the highest. Yeah, it's so weird. Yeah, I guess it's not. I think maybe it only just needs to be this. Maybe it doesn't need to be max 102, 102. I'm gonna submit this, but really I'm really not too confident about this. This is a very strange question. The one thing I do like about this is this sort of reminds me of like what medium questions I know can be like, but I'm not even sure if this is the right solution. So before I even speak about that, let's submit this. 11, 22, 11, 33, 11, 33. expected 33. After this 11, it's once. After this 11, it's twice. After this 11, it's twice. So anytime we see an 11, we see the thing that has the highest priority. See, this is weird because this should, I feel like this should work. If it's key, max equals max priority queue dot front dot element. It'd be really nice to be able to like print this out every single time. But I just know that's going to be so slow. But I feel like that should work, right? Because let's go through this. Let's say this is our frequency. And let's say this is our queue. So we go over here for nums of I equals key, which is not. Okay, so we're going to do frequency of nums of I. 33 is 1. And here we're going to have element 33 with a priority of 1. Okay, now we come to the next one. If it's key, okay, so max a priority queue. So right now we get 33. That's like the highest thing. Then we get to the next thing. We have another 33. This is 2. We on queue it. That's fine. It's 33. Get to the next one. 11. Max is 33. Get to the next one. 22. So now we have a 22. We have 1. 22 at 1. That should sit below. Then we come to the next thing. Max priority queue of front dot element. It should be element and priority. Are we not? Am I not getting the right thing here? If it's key and max priority queue on queue. On queue name, lowest priority. Where priority is the turn, for example, 1, 2, 3, 4. The priority here should be the frequency. Am I not? Maybe I need to be. I guess the frequency doesn't really matter. Frequency of nums of I equals frequency of nums of I plus 1 or 1. We on queue the element nums of I, and the priority is frequency of nums of I, however many times it comes up. Man, I feel like we're so close to this one. Okay. Anything else? I guess I'm gonna have to try it out. Let me just see what priority does here real quick. I'm guessing that's not gonna be right because priority should be the count, the frequency, right? Yeah, 2, 3. So if I do this, if I remove this and I just put 11 as my key, what is my priority here? My priority is 2. Okay, which seems right. But why would 11? Am I? You know what? It's because I'm adding 11. I don't want to add 11, right? If nums of I equals key, we only check the max, but for anything else, I guess I don't really care about adding. I probably don't care about adding anything else but that. $33 and 33, but then the other ones fail. Now this is 3, so why is that one 3? And the key is 2. But then I'm never looking at the 2s. That's so interesting. When should I add a 2 if I'm looking at this? Like I need. Like it could be a key or it could not be a key. So maybe, you know what? I can probably add the key So if it's key, the max here, before I ever add it, should be the thing with the highest priority. Oh, and that's still going to be 11. It's not going to be 33. Probably I can use some other, I can probably, maybe if I had a max heap that also took into account like count or something, yeah. Because if there's two with the same, I see for target 3 is only one occurrence. Following the occurrence of key maximum count. Return the target with the maximum count. The test cases will be generated such that the target with maximum count is unique. So if it's unique, how is, yeah, this might be very easy, but I totally overthought this, and I'm not sure, you know, this is almost taking the entire stream, and I really would like to get to another one. So let's see if we can do one at least before the stream ends today. Given a binary string s, return true if the longest contiguous segment of ones is strictly longer than the longest contiguous segment of zeros. Okay. Let's see. Gonna have some water real quick. And I just spilled a ton of water on my shirt, but you know, it is what it is. That's just how things go sometimes. Note that if there are no zeros, then the longest continuous segment of zeros is considered to have a length of 0. The same applies if there is no ones. The contiguous segment of ones has length 1, 1. The longest contiguous segment of zeros has length 0. Longer than the longest continuous segment of zeros. What if, I wonder if we can do like Hamming weight here. Could we? Maximum 0. I almost feel like we can sort of, like, let's say 0 and 1. They each have 0, right? So we look at the first thing here. If this is 0, we increase 0. And we can remove this one, right? So now the next one's 1. So now we have like, if the next one is not like a 0, we can get the maximum of this. Now we have 1, 1. Okay, then we have 1, 2, 3 zeros, which is greater than the previous one. We have 1, 1, 1, which is not greater. 1, 0, which is not greater. We have 2 ones, which is greater. Segments of 1 is longer. Oh, okay, that was a different one. Which one did I do? Oh, here. Length 3. Okay, yeah. So I think we can do that. And let me think about this. Like I kind of like that solution there. But we also need to know how long do we do this for? I guess we can do it while the number is not 0. But, and I just realized this, yeah, this is a string. So it's actually even easier to do, I think. So imagine we have a string and we have a pointer. If it's a 1, we keep track of the ones. Else, yeah, I think we can say let ones equals 0, let zeros equals 0, or let I equals to 0, I less than s dot length, I plus plus. Whoa, I'm not sure what happened there. Here, let's say let max zeros or max ones equals 0, let max zeros equals 0. Okay, so if s of I is equal to 1, else, okay, so if s of I is equal to 1, what do? We say, actually, when is it that we, So you have 1, 1. Okay, now we have a 0. So now we have to sort of go to the other piece. Like we definitely want to increase ones plus plus. And we should also say that max zeros equals math. Wow, I can't type right now. Wow, math.max of max zeros or zeros. And zeros equals 0. And I think we can do the same thing down here. We'll say zeros plus plus. Max ones equals max of ones or ones. And we'll say ones equals 0. I think this can work, but let's see. Okay, so s of I equals ones. We'll do ones plus plus. Max of zeros equals 0, 0. That stays as zeros, and zeros is 0. Get to another one. Ones plus plus. Cool. All this remains the same. We get to a 0. So as soon as we get to 0, we can do zeros plus plus. Max of ones is max out math of max of ones or ones. So now max of ones is 2, and ones becomes 0. And we got to the next one. We'll do ones plus plus. Max zeros is math.max of max zeros, 0 or zeros, which is 1. So this is 1, and now zeros is 0. Come to the next one. Zeros plus plus. All right. Max ones is math.max of max ones or ones. So it stays the same. Ones is 0. Come to the next one. Zeros is 2. All this remains the same. Come to the next one. Zeros is 3. All this remains the same. Come to the next one. Now it's ones. We do 1 plus plus. Max of zeros is math.max of max zeros or zeros. Here we have 3 now. Zeros is 0. Go to the next one. We're at a 0. Zeros plus plus. Max of ones equals math.max of max ones or ones. Stays at 2. Ones is 0. And here the answer to this, it should be if this should be false, right? Yeah, for example, the longest continuous has length 2. All right, so max ones and max zeros. Now, is there any way, I think just for good measure, we should return math.max of max longest continuous segment of ones. So max ones or ones is greater than math.max of max zeros and zeros. Let's remove this. See, like, well, we'll see what the answer to this is. But just to show you, some questions are good and I could do them relatively quickly. But again, let's, before we start saying anything, let's see the answer. We got true and true. All right. True, false, false, true, false, false. Let's submit it. Nice, 97.22 and 98.15 for space. Very, very nice. I really like this question. Again, just to show you, the previous question that we were on, right? I mean, I'm not saying this is entirely terrible, but a lot more people dislike it than they dislike this one. So if you're faced with a question that you can't get right, don't feel so bad if a lot of people are disliking it. You know it's not exactly a good crafted question. It can be disliked for any number of reasons, but this question, look at the like to dislike ratio, look how quickly we were able to solve it, right? So just goes to show that high quality questions sometimes are way more worth like the struggle, and they'll generally be easier in the sense that they're more straightforward. So don't feel bad if you're struggling on a question that has a terrible like to dislike ratio. Anyway, I'm probably going to wrap this up now. This is going to be the first video of its kind that I set to like premiere at a certain date. So I hope you all enjoy this. I know it's a shorter video, and I know we spent the majority of the beginning sort of figuring it out, this question, which honestly was terrible. Let's see what we have in store for us on Sunday. Longest uncommon subsequence. Wow. This has got to be one of the worst questions I've ever seen. I probably will skip that one. Special array with x elements greater than or equal to x. There exists a number x such that there are exactly x numbers in nums that are greater than or equal to x. There are two values, 3 and 5, that are greater than or equal to 2. You are given an array nums of non-negative integers. Nums is considered special if there exists a number x such that there are exactly x numbers in nums that are greater than or equal to x. What? No numbers fit the criteria for x. If x is 0, if x is 1, if x is 2, x cannot be greater since there are only two numbers in nums. There are three values that are greater than or equal to 3. 0, 1, 2, 3, 4. And it says there are exactly x numbers in nums that are greater than or equal to x. I see. Okay. How can we figure this out? Like, for some number, there needs to be the amount of numbers that are greater than this number have to be the same. Like, there are three values that are greater than or equal to 3. There should be two values that are greater than or equal to 2, so on and so forth. But it could be a good question, but like I said, trying to keep this one a little bit shorter because I did a lot of streams today. But I hope to see you guys around on Sunday. I hope that the premiere works out well for everyone. Feel free to leave any comments, questions, concerns, anything in the comment section. Subscribe if you like the videos, and keep it up on LeetCoding. Take it easy, guys. Later.